Re-lubricate my bed, so I'm going to show you two things that have made this process so much easier. One glue side, one no glue side. Secret to cleaning is these nail technician pads. They're small cotton pads, but they do not have any lint whatsoever. They're meant for doing nails. Secret weapon, the up-C-down-Z squirter machine. Set it on the table, you press into it, and then the liquid shoots up into the cotton pad. And then you squubby wubby. Existing lubrication is gone. It's now time to do a fresh coat. Secret weapon number 2, this is a hairstylist brush that has the same type of bristles that came with the polymer itself. I can cover the entire bed surface in like 20 seconds. Literally everyone is talking about these Poly Maker filament dryer boxes. Filament box, hair dryer, desiccant pellets. However, nobody has seen the big picture. Because what about double dryer box with a top hat? They say that 2 wrongs don't make a right. But if I'm wearing 1 thong, then what does that make?
Can you give some recommendations for beginners programs to start 3D modeling?
I will never stop being an unpaid shill for Shaper. I actually started with this app on an iPad, and then when I got a Mac, I started doing it on a Mac. Because it uses the cloud to sync all your projects, you can bounce between the two. I started with 3D modeling a year ago, and I had no modeling experience, no modern modeling experience whatsoever. In the past year, I've designed over 50 products from scratch. In fact, my first project actually spanned 8 months with like 13 different parts. And I've only had to watch 2 YouTube tutorials on like how to do something. Everything else I've just figured out because this app is so intuitive. And their built-in tutorials are awesome. I don't think this feature is exclusive to Shaper, but it's the reason why it was so easily attainable for me. If I just wanted to draw a line, right? I drew that. And then I wanted to draw it this way. There's these purple guidelines that tell you when you are aligned with something. And just knowing that like, oh, okay, I can go straight. And then if I wanted to draw up, but I wanted to make sure it was at the same exact height, if you just touch this over here and then you drag to the right, it tells you. So you see that purple line, it shows you that you are exact and that you are exactly at 90 degrees. So let's say I want to do like not an exact half, right? I want to drag this down, but I want it to be a square with this point. Touch that point, drag it over, boop. So me not having any CAD experience, it made this so easy to grasp. This right here is some random angle, right? Let's just say I wanted to continue that with trying to make this triangle bigger. If I click here and then you like touch this line and then you drag, you can see there's that purple that shows, hey, you are directly in line and you are staying consistent. And you just drag. And it makes, you see all those purple guidelines that show up like, hey, that is the right angle. There's just so many of those really helpful things that make drafting with no knowledge of how to do things the right way easier. Biggest downside is the price if you try and pay monthly. But if you use the free version, you can have 2 valid projects at any given time. Just export the projects and then delete it and then start a new one just while you're trying it out. I love this app so much. Somebody else just discovered it too.
I just downloaded Shaper 3D. I'm shaking because of coffee, not because I'm so excited, but it could be.
Why not use a screw to tighten this bracket to the bottom of the desk? They basically mean, a screw like this that would screw in. Because you're right, this technology exists already. The issue is the more that you screw and tighten it, the more that this part bends. And we're not dealing with metal, we're dealing with plastic. The amount of tension needed to clamp this to the desk is going to put way too much pressure back here. It's going to snap. To try and make it not snap, you have to either increase walls, increase infill, more plastic, more waste. And even if you clamp the shit out of it, it might still move. In order to make that part strong enough and then the screw part strong enough, I don't want all of that extra bulk and plastic. And then because more of all that, it costs more. So then if your desk ends up being thinner than the clamp itself, this kit will just come with a bunch of super tiny, like thin spacers that you can fill that gap, and then the pressure of the screws going into the desk, just keep it closed.
Check out the big brain on Brad. You're a smart motherfucker.
I had an epiphany last night. I'm not opposed to using screws, just in the way that we were talking about. So then I thought, okay, what if the bracket comes down from the top, slides behind the desk? The bottom piece, also using dovetail, would then clamp up from the bottom. And then the 3D printed screw could then screw in here. And that would keep it from being able to move up and down. So the clamping force of this doesn't need to be so tight that the shelf doesn't move. It just needs to stop this part from going down, or from this part from being able to be pulled up. And then it satisfies my need of wanting to have metal screws that you can screw to the underside of the desk, so this doesn't move at all. Because who wants this? Nobody wants this. And the combination of the pointed screw and some sort of texture would pseudo lock that into place. That is how you give a nerd morning wood. So I'm finally printing Gridfinity stuff, right? And I just made an awesome discovery. There's already so many parts for the Alex drawer, which is like one of the most popular ones. But I have this guy, which is it's an Alex drawer copy. It's wider, it's taller, but it's not as deep. Just like me. So if you have this one, and you find the Gridfinity base by Pay3D, his model has this little lip on the edge of it. That little lip fits right in this crease. And you print 4 of those. It doesn't fit perfectly widthwise, but from front to back, it's actually the perfect size if you print 4 of those. The downside is these drawers don't come out as far as the Alex ones do, so you get some that are back there, but you just put your shitty shit back there. This might apply to only 2% of you, but just in case you're that 2%. Sure, you could make this work, but if you just want to be lazy, it'll work. If you are somebody who wants to get into the Gridfinity system, I'm going to give you 2 quick hacks that I think are dope. If you're somebody who buys these assortment kits that come with a bunch of different hardware, you might not necessarily want to group them together. Not only that, but as soon as you remove it out of there, you lose the branding. So to keep track, I used a QR code generator to take this QR code and link me directly to the Amazon listing where I bought this. Adobe has a free QR code generator. Use whatever one you want, but because I use the Adobe Express app to make images, I put that over here, and then I take a screenshot of the Amazon listing and then copy the title and the brand name. I just use these little thermal printers to print out the labels. And then even if things are separated, you know where they go and you know where to buy more. The second tip is because I don't have a large printer, I have to print these grids in pieces. And I didn't really want to deal with adhesive or tape to keep things down and together. So once you get them in place, you can just take a soldering iron and melt the ends together, and then they'll just stick. But do clean up these edges. Hey, don't cry. You can do this too. You can totally get away with not having a big printer and still printing the grids big. I told him not to cry. I'm just doing the upper drawer of this uplift cabinet. I'm going to make this one pretty though. This grid is actually in 4 pieces. What I did is I got them all situated. I placed them in and I taped these down with a bunch of gaff tape, like all over. Made sure that these all fit in their spots. Then you take a soldering iron. Oh my God, this has been on for 5 hours. Then you just join the 2 edges together, melt them together, breathe in those fumes. It's a little molten. You can kind of like smooth it over, make sure it's not bulbous. This could be you. It took nothing at all. Nothing at all. Nothing at all. This is my first successful print of a 3D printing technique I just learned about. I'm going to see if it worked on camera first. That and this is the part. This is a bracket that goes onto the back of the Elgato prompter, part of a whole kit I designed for it. The back side of it isn't great to print on if you were to print like this and try and do supports. Then of course if you print it like this, you have supports that go all the way up through here, and then you get all of that. And I know there's other ways to combat it, but I hadn't had time to test them yet. When you print it like this, for the most part it's fine, but because that is a lip, trying to then get all of this, like the support out of underneath there when it's PET G is awful. What this is only using PLA for the support interface layer, and then everything else is PET G. I could have done PLA for all of the support, but this is less wasteful. I made an Oreo, so you can see that white layer of PLA in there, and I'm hoping that this just... Okay, not as easy as I was hoping. Do I flex a little bit? Love me. actually snapped off. Not quite as pretty. I have a feeling that this isn't like the interface layer maybe was supposed to have changes. Like it's an interface layer, but it's supposed to print like any other layer. Now because a piece slides in, there's also one under here that I was hoping would just like come out. I don't think it's going to. Yeah, that one's not gonna come out. The white is the PLA. It looks like the Pet Jeep fused to it a little bit. Maybe the nozzle was too hot? I don't know. Good start. Good experiment. Creating specialized things that didn't exist is one of the main reasons why I love this hobby. The original piece of gear is the Axoon CMO 4K. The attachment that goes on a camera, it lets you use your smartphone as a monitor, so it gives you a much bigger screen for the camera and also some additional features. The core of the device is awesome, but this unit is so bulky, and there's these huge cables that come off the side of the camera, which I hated. And the mount wasn't MagSafe, it was clamp. I also hated that. The phone clamp part of it has a proprietary mounting system to the other half of the device. So I designed a part that had the same mounting system as this did that could mount to the other half of it. And then I added a 1/4-20 heat threaded insert so that I could take a MagSafe puck that would then screw in. I was able to make this part more low profile. I was able to add cable management loops to keep the cables tidy. And now everything's magnetic. Don't gotta mess with no clamps. Normally this isn't an issue, but these clamps actually covered the camera button or it hit the volume buttons on the iPhone. So with 3D printing, I was able to make this a better device and give it more life, extend the life of the product to work with a new phone that I had gotten. And I do that all the time. When they say possibilities are endless, they are literally endless. We're putting this 3D printer advice to the test. Spoiler alert. Hey, what's up? All right, this time I just tried a different PLA instead of the white PLA, and then I changed the Z distances to 0. Ooh. Uh-oh. Well, I mean, that's still better. Nice. That white filament I used before, that was Polymaker's Panchroma. This was just some eSun. It's actually heat sensitive filament. See how some of it's purple, some of it's pink? I'm gonna put it by the air conditioner. Now it's all purple. I got this filament when I bought my Ender 5 in 2001. And I still have the filament. And not sponsored, but if you haven't gotten the Super Tack plates from Bamboo yet, and you need bed adhesion, you're missing out. Moment of truth, this lip that has the overhang. Yes. Oh my God, I'm so pumped. Still some tuning to be done, but already so much better just by having 0 on the Z offsets. Printing all the support and the support interface in PLA instead of just the interface layer. It adds like 40 minutes, but I'm not complaining. It used to take me 10 to 15 minutes to get supports off of this thing before. That is awesome. Soldering iron recommendations. I'm gonna blow your mind. Fucking like that. Soldering iron you asked about. That's just like a cheap piece of crap, right? $10, whatever. I'm not gonna sit here and pretend that that thing doesn't work. A soldering iron, it's just a piece of metal that gets hot and it makes other things hot. That $9 one, that'll work. But this is the Pine Sol. Size comparison. This is the most over-engineered, awesome soldering iron ever. I use about 10%. It actually is open source. It has an LED screen on it. For power, you can do USB-C or a DC jack. My favorite cables of all time are these Anker Powerline silicone cables. Pair that with any USB power source. It has power, but it doesn't heat up until you actually press it. Then it goes. It takes about 15 seconds to get up to temp. I also have one for my little heat press station. I really didn't tell you much about it, but I love it. If you go to my bio page, I'll put shortcuts there for you, but otherwise you'll just have to ask Jeeves. Fume extractor recommendations. Why, yes. I'll be honest, this is the only fume extractor I've purchased, but it's worked great. I'm going to tell you about this setup, though. Fume extractor sitting on the desk, annoying. Fume extractor connected to a boom mic arm that you can adjust and float anywhere, the way to go. The fume extractor is actually underneath. I designed this little enclosure so that I could use a boom mic arm. This particular one has replaceable filters, so I wanted to be able to get to the filters easily. It's supposed to be a tight magnet fit, but I accidentally glued the magnets in the wrong orientation, so now it repels. We're about 4 inches away. Pretty good. If you go to my profile and go there, and then fume extractor mod, this is a full guide. You can download all the files, full parts and tool list, slicer settings, everything is there for you. I'm going to cut a hole in a computer case with this laser. It is this guy. We're going to cut like I wipe, from back to front. Thankfully, this is just the right size. We're going to test on this side first, so I just put a hole directly center. Did you say who's the CEO?
Yeah.
I am. Me with those thighs.
How about a gun?
Emergency!
What? What does that mean?
I don't know. That didn't do shit.
Wow, this is all being filmed. Do you realize that?
This is all being filmed. Moment of truth. Did it work? Shut the fuck up. We did it though. Woo!
Your identity's hidden.
Thing reeks of capitalism. Lesson one.
Plus one.
That looks great. A couple weeks back, we tested PLA as support for PET-G for the first time. I tried 2 things that were suggested by other people. One using Silk PLA as the support, and then a bunch of settings from C.S. Wilson prints. I'll tag them. It's separating from the PLA before it even separates from the bed. Now that little lip in there it's always been the problem child for me. Perfection. Here's what the PET-G looks like that was up against the PLA support layer. Buttery smooth. Buttery smooth. I got too excited I broke it. But it's a draft. It's okay. Shout out to this dude. That's his name. Or just pause the video here, you poopy anus. If you do all your own shipping and you do not have an automatic tape dispenser cutter for your water tape, you are missing out. $60 price tag was hard to swallow at first. Once it cut the first time, I forgot how much it costs. It's this one by Bempis. It's $64. I'm sorry. If you didn't even know this existed, you're welcome. If I wanted to design my own wrist rest for this keyboard, how would I do it? Start to finish process, so you know this is possible. It's called photogrammetry, and if I can do it, you can do it. It's the greatest part of 3D printing. This is my old wrist rest. I found this online. I cut it in half, and then I glued some random foam to it. It's time to go trash. First tool you need, ruler. Second tool, camera. First 19 times I did this, I just used my phone. I need to get something that is close to the bottom curvature of this board. Camera on, lights real bright. Keyboard, camera, it's on the computer. Ruler in the frame, very important. Crop that screenshot, and that's pretty good. You don't need a camera. It can just be your phone, straight down. Return to base, because I need a keyboard to work. Import that photo into your drafting software. 300 millimeters on this ruler. Draw a 300 millimeter line. Scale this image up or down so that the 300 millimeters here matches the 300 millimeter line. That is looking pretty good. Trace over that edge till we get a loose idea of that design. You can even trace around the object that you want to design around so that you have it in software. Make a copy of that bottom edge, and then you got your first draft. Get a couple iterations going. Since this item is too large for my build plate, you can use Bamboo Studio to cut it and add a dovetail. Now you've got 2 pieces that can connect together. And then with a little 3D printer magic, you've got your first prototype. And it looks pretty good. If you're interested in more of the details of that process, my name on YouTube is the same as my name here. I did a 20-minute deep dive into how I do that process from start to finish in case you need it. If you are into 3D printing and you don't know what this is, I'm about to make you love me. I got a lot of questions about the heat press. This is a heat press. Hands down, one of the greatest tools to have. A heat press is just any device that lets you press threaded inserts, or heat threaded inserts, into 3D prints. You're pretty much melting that insert into the print. Having a heat press like this allows you to have your part perpendicular. And this is just a soldering iron with a special tip that is meant for these inserts. And then you press it. And then you can just be screwing whenever you want. So when you buy this, you get the press and it comes with a soldering iron, not this one. I'll show you the one I got here in case you want to look it up for yourself, but if you want a shortcut to it, I'll have it on the My Favorite Tools on my link. It comes with a soldering iron that is perfectly adequate for this. But I love my Pinesil and I love my USB-C power cable and my power adapter. If you're looking at this and thinking, oh, it might be too complicated for me, you can do this. Step 1, buy that thing because it's great. Step number 2, buy your threaded inserts. When I first started out, do you want to know why I buy the expensive version of these? These ones were the first ones I ever bought because they told you exactly how to make the hole on the packaging. Not only are they quality, marketing genius because that turned me into a customer, but it also gave me the confidence to try this for the very first time. And now I have an emotional bond. Fun fact, I have found if you do the Ruth-X measurements, that also works with the McMaster car threaded inserts. Now get out there and press some heat into some prints and tell them Nicholas sent you. I'm going to show you how easy it is to do this, okay? I can do it with one hand. In design software, I put a hole in my part. I promise it doesn't always go in this easy. That's what she said. Sort of lined up. Just eyeballing it, right? It's his job to keep everything straight. You don't got to worry about it. One finger. Okay, maybe 2 fingers. I have weak hands. Don't even have to press hard. Just let the heat do its thing. Look at it go. Look at it go. And when you reach balls deep, you just let go. And it's done. You can do this. You are totally capable. I believe in you. What other things have I used threaded inserts for? I have a bunch of different sizes. You never know which one you're going to need. By far the most common one I use is the 1/4-20 because that is one of the most common threads on camera equipment. The first time I ever used threaded inserts was for this. This is the Elgato prompter. It's a teleprompter. I designed a whole 3D printed kit for that prompter. Those thumb screws I designed all use that threaded insert. This is just a bracket for the camera. Also a 1/4-20 screw for securing the bracket to the prompter. Also in the camera department, this little guy. Axon CMO 4K lets you use your smartphone as a monitor for cameras. This whole mount never had MagSafe. It always had a phone clamp. I hate phone clamps. Threaded insert in the back, along with this little guy. 1/4-20 threads on the back. And now, that bitch got MagSafe. Woohoo! 2 more real quick. This is an iPad Pro. I designed this 3D printed bracket so that I could convert VESA to 1/4-20. At Stream Deck Studio. Floods because I designed a bracket that had 1/4-20. All thanks to 3D printing. Last month, I asked everybody what their go-to PETG filament was. By the way, thank you for those answers. Bought a few of the suggestions. I already had some of the other ones. I'll show you all the ones I bought, and then I'll tell you my favorite. Spoiler. My favorite is the cheapest option. Prusa's PETG comes in at like 30 to 35 USD for a kilo. Surprisingly, the most problematic took the most filament tuning, and I had the most failed prints with that stuff. I really only use it on this printer because it's the only external spool printer I have. Once you got it tuned, it was great. Just really, really glossy. Too glossy for my liking. Not only that, their holes are smaller, so they don't fit on this unless you Hercules it on. Both of my spools were slightly warped, and they don't work in the AMS. So as somebody that uses bamboo, not a great choice for me. I already had some bamboo PETG, which people keep telling me that bamboo is just polymaker. Oh, look at him. He's just a wee lad. When you buy bulk refills, that comes in at $15 a kilo. Print's great. It's a little glossy for my liking. Next, we have 2 from Elegoo. The Rapid PETG and then the PETG Pro. When you buy in 2 or 4, I think this comes in around $12 to $15 a kilo. This is probably second favorite. And as far as the finish goes, look at the difference in shine between the Prusa and the Elegoo. For a part being sold, I picked this one 10 times out of 10. And then finally, the winner. Sunlu. Oh shit, I didn't know that. $44 for 4. Because I have Prime, it arrived next day. That is $11 a kilo. The matte finish is very similar to the Elegoo, way less shiny compared to the Prusa. The only downside is the spool hole is larger, and it's a little loose on the AMS light. I get worried about that. $64 for 4 refills shipped. It would have been $75 if I got them with the spools. $44 shipped. Comes with the spool. Got here next day.
And as somebody who uses bamboo, Sunlu's the winner, dude.
On Amazon, they have this roll, and then they have this roll. They look exactly the same. This just says regular Sunlu Pet G, and their high speed is their matte finish one. So if you scroll down, this is the one you don't want if you want matte. But if you look at the high speed one, it doesn't say matte in the title, but if you scroll down, it says matte right up here. And actually, right there. If you're feeling lazy, I have a shortcut in my bio to get to it. Of course, disclaimer, these are all commission generating. If you ship all of your own products and you love and use water tape, but you hate the water aspect of it, this life-saving tip is for you. This is shipping tape with water-activated adhesive. Think Amazon boxes. The worst part about it, ironically, is the process of getting it wet, which normally I don't struggle with. They make contraptions like this that lie to you, tell you that it's going to be okay. It's not.
You tried getting the rag wet and it sucked.
Here's what you need. The bottom of a glass butter dish and your sponge of choice, slightly moist. Take one end of your tape, press it in, move it over a little bit, put your hand down, pull it through. Press that on there. Yoink. Yoink. And you're done. The butter dish is conveniently perfect size for the sponge, almost. Weight of the glass keeps it in one place. Pulling the tape against it, this lip holds the sponge in place. You get to use both of your hands instead of trying to hold the rag with one and the tape with the other. That sponge is just slightly higher than the glass. The water stays contained in the dish. Because this retains water so well, if you need a little bit more moisture because it's drying up, you can just press into it. And then if you forget to put this away, you just leave it out. All the water just evaporates. It dries up on its own. If I told you that this was a perfectly functioning screw, would you believe me? Because it is. I know it looks a little funky, but it totally works. I learned of this trick a year ago, but I didn't actually utilize it until now, and I want to share it so that you know when you need it. 3D printing screws is difficult because if you print it this way, you don't have good strength because it could break on any one of those layer lines. Now you could print it this way, which would give it much more strength, but with this particular screw, the threads are completely off the build plate. Even if that big part was gone and you just printed it like this, little to nothing is making contact with the build plate. The trick that I learned, shout out to whoever made this video like a year ago, is that you can shave the sides of the screw to make a completely flat surface. It looks so goofy, right? It prints like that. All right, there's the deformed screw, round hole. Fits as it should. Oh, this is hard with one hand. Oh. And then just like that, just like a regular screw. See, on the left, I took just a little bit off, and on the right, I took a lot bit off. Even the one that I took a lot off, it works all the same. You don't really have to be exact with it. This whole project is now possible because somebody decided to share a cool tip like a year ago. So I'm hoping to do the same for you. I'm actually glad you asked about my little nubbies because I could use some feedback. I've been playing around with different designs for the tip of the screw to provide grip. The basic idea is part number 1 comes in from the top. Part number 2 comes in from the bottom, and then the 3D printed screw secures this in. The tricky part is finding what type of design to have here, and then what type of design to have on the end of the screw. Having the 4 tiny pyramids on the end of the screw did work pretty well. It creates a little bit of wear, but those ridges are super strong. And then of course the end of the screw gets a little bit worn too, but it still worked even after like 10 or 15 cranks. Just cranking your motherfucking hog. All right, so that part goes up, it screws into place. This amount of force would never happen, but it is like really solid. So I think I'm going to end up going with that design. You can already see possible problem there, but yeah, the little teeth on the edge of the screw just kind of dig in. Just digs in right there, and even though it does a little bit of damage, it still works. So if you have any ideas, let me know. The only restriction is it can't, like, it needs to be able to lock in place wherever it's at. I can't have it adjust, so I can't have like pre-drilled holes that it can lock into. It has to be able to be adjusted to any height. This little gap right here has to be totally universal. The screwing continues, and we have made some great progress. A few people suggested print in place, which I've never printed or designed anything print in place, but we did it tonight. So that is pretty much what I came up with. So I put a thick nipple dick ball on that side, and then I just did a subtract on that side. From the videos I watch, if you know what you're doing, you can do print in place without having to cheat like I did. And so I cut out the bottom there so I could just support this end. just put a tiny hole in the top so I didn't have to support the big dome, and I could poke at it if I needed to free it. With the right knowledge and technique, you shouldn't have to do either of those holes, but I have found that trying to find those right settings at this size is pretty difficult, and this works. Here it is in the slicer. Starts with that support, and it goes up, and then it turns into that ball joint, keeps going, and it took me a couple tries, but I got it. I did it. I'm also testing what surface I want for the grippies, and even though the screw in there right now is flat, like this thing, it's not going anywhere. So that design on the right will probably be the winner. It looks so goofy in the software. And then I'm also going to test that.
It's so cool.
It's going nowhere. I got you for 3 minutes.
If you're just tuning in for the first time, I've been working on this 3-part bracket design. This is for a desk floating shelf project I've been working on for months now. The part that has consumed my life for the past 24 hours is this screw. This is my first ever print in place design, and it's the first time I ever printed something that was print in place. But it ended up working out. Hot plate, incoming. Oh, I love when the supports stay on the plate. That's awesome. This is that main bracket, and this is the modified back plate. Actually, I just have one dovetail now instead of the two. So this is the back plate. This is kind of the screwy wedge. A little tight. All right, then we got our brand new screw that has a print-in-place spinny top. Come here. I can't believe this works as good as it does. Very surprising. I ended up shortening the screw. It didn't need to be as long as it was. These are working out great. Well, that goes in, start screwing. That spinning plate locks into that area, and it's going nowhere. That is rock solid. So yeah, it spins, grabs hold, and tightens. It works great. I also switched from the dual dovetail to just a single dovetail, and then I put a hole in the middle for where that screw can make contact. That ended up working out pretty good as well. You don't think you make that many changes, and then you go back and you look at all of the iterations and all of the STLs that you've exported and how many different little tweaks you made along the way. And yeah, for this part here, I ended up just matching that same surface on the edge of the screw, and that's what is right there. And that ended up working perfectly. Trying to make it so it's completely universal and doesn't require additional hardware other than the 2 screws that you have to screw to the other side of the desk. So now I just need to work on the tolerances for the main dovetail. Now, Cookie Cat is my favorite looking filament ever. I thought I was gonna have to print these screws in PETG in order for them to be sturdy, but this is gonna be really sturdy. The only thing left to do is to make this less bulky. I wanna have a bulky version that can be really sturdy for heavier things, but I also kinda wanna have a low profile version. But this is pretty bulky, and I think it can be slimmed down, especially if this is gonna be in PETG.
It's going nowhere. I got you for 3 minutes.
If you're just tuning in for the first time, I've been working on this 3-part bracket design. This is for a desk floating shelf project I've been working on for months now. The part that has consumed my life for the past 24 hours is this screw. This is my first ever print in place design, and it's the first time I ever printed something that was print in place. But it ended up working out. Hot plate, incoming. Oh, I love when the supports stay on the plate. That's awesome. This is that main bracket, and this is the modified back plate. Actually, I just have one dovetail now instead of the 2. So this is the back plate. This is kind of the screwy wedge. A little tight. All right, then we got our brand new screw that has a print-in-place spinny top. Come here. I can't believe this works as good as it does. Very surprising. I ended up shortening the screw. It didn't need to be as long as it was. These are working out great. Well, that goes in, start screwing. That spinning plate locks into that area, and it's going nowhere. That is rock solid. So yeah, it spins, grabs hold, and tightens. It works great. I also switched from the dual dovetail to just a single dovetail, and then I put a hole in the middle for where that screw can make contact. That ended up working out
pretty good as well. You don't think you make that many changes, and then you go back and you look at all of the iterations and all of the STLs that you've exported and how many different little tweaks you made along the way. And yeah, for this part here, I ended up just matching that same surface on the edge of the screw, and that's what is right there. And that ended up working perfectly. Trying to make it so it's completely universal and doesn't require additional hardware other than the 2 screws that you have to screw to the other side of the desk. So now I just need to work on the tolerances for the main dovetail. Now, Cookie Cat is my favorite looking filament ever. I thought I was gonna have to print these screws in PETG in order for them to be sturdy, but this is gonna be really sturdy. The only thing left to do is to make this less bulky. I wanna have a bulky version that can be really sturdy for heavier things, but I also kinda wanna have a low profile version. But this is pretty bulky and I think it can be slimmed down, especially if this is gonna be in PETG.
You know what I think?
I think that's a great idea. So instead of doing a flat bottom, do a little bit of a cutout, put some nipple dick holes, little TPU pad with some nipple dick nipples. Those nipple dicks will be circumcised.
Rigged for her pleasure.
Design that to shove in there. So I made a little cutout and a little pad and push. Hey, look at that. This is 95A TPU. It needs to be softer to get more grip, but I mean, that's gonna work wonderfully. Look at that, it can even come undone too. This is my second TPU print ever. So these are the same parts. This one's just cut a little short. Little pad there. Boom. Probably do one on the underside over here as well. Hell yeah.
You can do whatever you want when it comes to 3D printing, except print TPU on dipped PEI plates, because then the only thing you will do is destroy your build plate. Where are we at with the universal floating desk shelf thingy? So far the design with this screw is working wonderfully. The whole point of this being you can take whatever piece of wood you want with these universal brackets and make your own floating shelf for your setup. Thanks to some smart people in the chat, we now have little grippy TPU pads on the top and the bottom of the bracket. They print as 2 different pieces, and then you can just insert that in there. You go to put this together, both the top and the bottom of the clamp are going to have a little bit extra grip and sound absorption. I'm still undecided on this. I might offer 2 different versions, one that has a side that the piece of wood can go up against so that you can secure it from the sides, but I also want every bracket to be able to be secured from the underside to hide the screws. The wood will go right up against it. Screwing into the sides of the wood is worse than screwing to the undersides, but when the wood is in place and your bracket's already set, screwing in from the sides is easier than trying to get a screw underneath and screw upwards. While this new version I'm toying with, you can put this bracket anywhere you want. So if you also wanted to buy an additional one to support in the middle, you could do that. A couple of revisions back, I had this topper piece that dovetailed to the top and that would clamp down on top of the wood. I think I gave up on this design. The reason this is angled forward is so that if you have a monitor with a monitor arm, the shelf will be in front of that. I wanted to give people the choice of having a really deep piece of wood or a shallow piece of wood, just for the ease of installation, having this little insert so that when they are getting their stuff ready to go, they have something to butt against it to make sure things are at a 90-degree angle, nice and straight. Now, of course, one size isn't going to fit all, and I'm probably going to offer 2 different height sizes. One that's enough for any keyboard and mouse to go underneath, and then a higher version which typical gamer streamer hardware like Elgato stuff can go under. However, making this any taller means it's too big for my build plates. I didn't want to do this, but I might have to, of separating this big angled piece into 2 pieces that can securely go together. I need to verify that it's going to be as strong as I want it to be, but I'm thinking with PETG and this dovetail big enough, it'll be fine. This only has 1 wall. It's fragile. It doesn't need that type of strength. All the strength is going to be here. And we'll see what happens. 3D printing lighting hack, and I promise it's not that, but close. I just got done moving. I'm so tired, but this is the new workshop in the basement. I'm pumped. Turns out that these lights that are meant for like garages and attics, they're super bright, are really good for lighting the inside of a P1S. Having the AMS up top always annoyed me, so I've always had lights that I've put on top, and it just blasts light into this little box. It's great. You can't even tell that this used to be a lamp that I destroyed.
Huge shout out to Knackers. If you've not seen his videos on his modular floating desk shelf where he designed a whole modular mounting system.
So 3DD is looking for some design pointers. 3DDs. D's nuts. I don't know much, but I know this. I am not qualified to give any pointers, but I might be able to help. My box of working prototypes. So the one thing that my design has that I don't think yours does is I have a wider wedge and then these two screw holes. The whole point of that was so when they put the shelf bracket here and they clamped it down on the desk, I didn't want to rely on clamp force to keep this in one spot. This wedge isn't meant for clamp force. It's only meant to stop this whole thing from coming up. And the screws that go into the bottom stop it from going left and right. I don't know if you saw the follow-up videos, but I moved to a different screw design where this just have a bunch of micro ridges, and the screw actually has a spinning top with some of those same micro ridges. A byproduct of this design, because this screw is not in the center vertically, when this screws in, it actually kind of bows a little bit and gives me a little bit of clamping force. I also did go down the route of printing some TPU pads that provided some extra grip. So you can see when it's tightened, it inverts in a little bit. That's still probably not going to be enough grip for what you're looking for. I didn't go down this route, but when I was designing this, I had a bunch of people saying there was a certain type of teeth design that you could do on the wedge or on the screw that when you would screw into it, the design of the teeth would provide clamping force. It was either like sawtooth or 45-degree tooth. It was some type of like wedged teeth that added clamping force. So my solution is I'm going to be providing screws that just screw into the bottom of the desk a little bit to keep it in place.
If you like to make and craft dope shit, then you've probably had an instance where you thought, how can I do something nice for the person that bought something while also standing out a little bit? This is an idea that I came up with, and I'm just kind of sharing it to give you inspiration. So far, I have designed and sold 4 different 3D printed products. Before I sell a product, I do a beta testing window where I send kits out to people to test and then give me feedback. Then when the product officially goes on sale, the first 10 or 15 people who buy that product, they get a bunch of extra goodies for getting the collector's edition. Beta testers get the kit for free. They just pay for the materials. So they get a 3D printed card that is filled with resin. The people get the collectors. This is a all resin card. This card was actually made from my own silicone molds. I made those using 3D printing. And then any filament scraps that were generated from the creation of the product, those get cast into the card with resin. With each card, everybody gets a little stand, and a little certificate of authenticity.
If your 3D prints are failing like crazy and you think it's the humidity, you're not really sure what it is, do yourself a favor. Check to see if your HVAC system has a humidifier. And if you have one, check to see if it's on. And if it's on, check to see if it's turned on to max. Couldn't be me. It was me. That's why it's so fucking humid here. I've never had central air in a house as an adult. I've only ever had window units. Didn't know that was a thing. This is what it was set to until today. Also, if that helps my next electric bill not be $480, that would be nice. It's a 3-bed, 1-bath. I only live with one other person, my queen. We kept our thermostat at 76 all month, $480. These power bills are getting crazy.
Look at this 3D printed object and tell me if I got my support settings down or not. Oh my god. Elegoo Rapid Pet G, but this is the bamboo support for PLA and Pet G. I struggled with this for weeks, but I finally got it. This is Elegoo, but just the interface layer is that support filament. Look at that. Finally. I love you. I just made a major filament mistake, and I got saved by National Geographic. Story time, baby.
I bought something new that I've never used before. I'm super excited.
Jesus pigs.
Just kidding. It's Elegoo filament, but glass fiber Pet G. Go-to Pet G is the Elegoo Rapid Pet G. I've never printed glass or carbon fiber anything. I'm after a more matte finish. Why don't we just... a beautiful spool. Already, I am aroused.
I gambled and lost. I was going to use this video to show you what the filament looked like. I went to go put it on a bamboo spool, and it doesn't fit. The spool is like a millimeter too small. I'm sad.
This is now a rescue mission. I put a shirt on. I'm trying to do this by hand.
it's... I never printed a respooler. I need to find a way to hold that spool together. Got long bolts that are drywall hangers, like anchors, drywall anchors. I need a big washer. Yeah, perfect. Yeah. I think these are Imperial. Quarter 20. Give me. Son of a... This... Nice. Motherfucker. Look what I found. Random piece of metal from a monitor arm kit. Big bolt.
Up from underneath.
Other plate.
Nut.
It has to. I don't have any choice. I'm now going to undo the hand respooling that I was doing. I've seen people on the internet do this. My queen has a rock tumbler. Did it. That was like an hour and a half. Thank you, National Geographic, for saving my day. All right, Prusha, you got me. Y'all cooked with this galaxy filament. 0.12 layer height, and then the Hilbert curve top surface, give it some texture. And it is looking fabulous. I'm a fan. Yeah, nice.
I've never even dreamed of cheating on my girlfriend. And now ever since joining this hobby, the possibility of me staying faithful is getting to an all-time low. I was talking about cool 3D printer setups and some dude was like, yo, VESA mount for the AMS light. And that's what I did. And now I just have to find this dude and kiss him. And this might be the smartest dude I ever known. So I got the AMS light vertical hanging on that VESA arm. And then I got this filament dryer hanging on this VESA arm for this one. It's just so lovely. I gotta find this dude. Y'all were telling me how to fix my A1 Mini, and I was listening, but I didn't understand. Let me show you how a simple miscommunication led me real astray. If you have an A1 Mini and you've never done any sort of maintenance, this video is for you. The TLDR is, there's just screws that need to be tightened. I thought I was tightening the right screws. I wasn't. I'm gonna put this into maintenance mode. I got the feeling this nozzle's getting hot, hot, hot. Removing the hot end is simple. Open this clip. Don't do it my way. This is the wrong tool for this. When I first opened this printer up, these were the 3 screws that were loose. That was only half my problem. And there was a lot of comments that were like, hey, just make sure you also get the screws behind it. I'm from Michigan, you see, America. Behind means behind, as in those screws behind this. What y'all meant was on the back side. Front side, back side, behind. These are the 4. 1, 2, 3, 4. Not 1, 2, 3, 4. I bet you 10 doll hairs one of these about to be loose. Oh, yep, look at that. Oh. I'll show you. This person's standing in line facing this way. Hi, are you in line? Yes? Cool, I'll get behind you. Try that again, but the wrong way. Hi, are you in line? Yes? I'll get behind you. See what I mean? I'll take the blame for this one. When it comes to drafting software, I can't recommend any Shaper tutorials, but there's an interesting reason why. I started drafting in Shaper on an iPad, and then I eventually moved over to a Mac. Started like a year and a half ago. I just recently completed my 126th drawing. In that time, I can only think of looking up one tutorial because the app is just that intuitive and easy to navigate. The one tutorial I looked up was how to make a screw. I made the one screw and then I could never do it again. Screws are hard, man. If you're already fluent in Fusionese, you'll probably do just fine. It's just a matter of learning what's different. But in my opinion, this is one of Shaper's biggest strengths, is being able to just jump in and start doing stuff. It's not the best app for everybody, and it has its pitfalls, of course. I exclusively design functional 3D prints, so I don't do any like organics or like trinkets or toys, and I've done no parametric modeling so far. I think that's a pain point for some people who get into Shaper. Not everybody drafts on multiple devices, but it is so seamless from iPad to Mac Mini to Windows. Some days I'm up here drafting, other days I'm in the workshop. I love it.
Not enough to not complain about that price though. Now there's a flip side to this. I went into Shaper with no knowledge and did everything I needed to with a single Apple Pencil. If you're like an Uber keyboard hotkey god and you got a Space Mouse wireless Logitech MX Master 3 all torqued out, you might open up Shaper and try to do the simplest thing and go, why is this stupid? What are you gonna do, huh? Here is an example of another design technique I learned recently where you actually design your supports in CAD. Ooh. So it prints on an angle. I get all the benefits of the strength. Pretty clean break. You can barely see those touch points. Another one. Oh yeah. 3 for 3. Sweet. And those contact points are on the back of the part, so when installed, you can't even see them. Woo! In CAD, this part is only a millimeter thin. Spaces are aligned, so they're touching but not overlapping. And there's only 4 little points where it touches. Real tiny! So it's a millimeter wide, and then there's 2 millimeters worth of contact for each point, 4 contact points. I could probably even get away with 2 if I wanted. Honestly, they've printed like this just fine if you got a clean bed plate. But with this Strat, I have 0% failure. Little pig, let me in.
When you press it and spin it, the TPU doesn't spin. I like sharing design ideas that ended up working well. Let me show you about this one. What I needed was a movable universal way to provide support to a shelf in case you wanted to use a wide shelf and support it in the middle. This little screw action changes the height. You can think of this as bolt and nut. There's a small cutout in the top of this that allows the TPU gasket to be pushed into place. It adds friction to the screw, pretty much acts like a Chinese finger. Screw goes in. And now it's stuck. And you can rotate this to any height, and that TPU gasket pretty much stops it from wiggling or moving at all. And then both the top and the bottom have it's pretty much like a dovetail cutout that allows these TPU inserts to get pressed into place. A tight enough fit so they don't come out, but loose enough so that it spins a little bit. So when you put it under the shelf and you start adjusting upwards, it can spin freely.
I'm so mad I'm just now printing the TPU. I should have started so long ago.
Is it hard to learn CAD? Maybe? Does it depend on how you learn and what software you choose? Oh yeah. I don't necessarily think CAD is hard. And if you're watching and waiting for me to recommend Fusion 360, don't hold your breath. Thinking about it in like Halo difficulty settings, it's not legendary. Whatever's right above that. Heroic is a skill. CAD is challenging, but with where software is at right now, I don't think it has ever been easier to learn it, especially with tools like Tinkercad, Shaper 3D, and Plasticity. You already know Blender. I've never used Blender myself. I've seen how Blender works. If you can stomach that, I think you can stomach CAD. There are certain CAD softwares that work based on what kind of product you're looking to build, and then there are other recommendations based on what type of person you are, how you learn, and like what you find intuitive. Graduated high school with like a 2.2. I went to community college for graphic design. My 15-year career in IT, all self-taught. 3D design, 3D printing, all self-taught with the help of YouTube and other creators. First 3D model I ever rendered was in Tinkercad, and it was this. I spent some time in Tinkercad, eventually went over to Shaper 3D. I've been there ever since. Now, if you told me you wanted to model characters and creatures, I would not tell you to go Shaper 3D. To me, it is much more of a functional design, like parts, manufacturing. I don't know how modeling organics would go in Shaper. What I can say is that I was able to get started with Shaper with an iPad and a finger. I eventually started using a stylus. I was modeling things in real life, I was like, okay, outer diameter, 73. When I first loaded up Shaper, I'm like, okay, well, I sketched, and yeah, I need to draw a circle, and I need that to be, 73. I want it to be, 3 millimeters thick, so 76. I said, oh, it's highlighting. I could probably, boom. I have a 3D object. I am a god. Shaper made taking those first very uninformed steps so approachable. The interface was intuitive, and first ever design was March 2024, and I just started number 132 this week. You can do it. Do it.
I love tape. I use it every day. These are 3 tape mods that I've done in my workshop. Yeah. Also, what up, dude? It's good to see you on my For You page. I love your videos. Anyways, tape mod number 1, I took this tape dispenser and I just bent it, and then I screwed it to this MDF board. I put some magnets on the bottom so that it sticks to the fridge, so that when I grab tape, it doesn't move. Which brings me to tape mod number 2. This is like my main drafting station. Somebody had a modular tape dispenser on Maker World. It's meant for tabletop. I just redesigned my own plate to work with the wall control pegboard. It's got those little hooks right there. And then I redesigned this part to be like a triple action part. I can either grab a piece and tear it on the end with my hand, or pull a piece, get a razor blade, and then make a super precise, super clean cut because I'm weird and I like that. Or I can take my scissors, and I left a big enough groove that I could put scissors under there and do a cut. And the tape still stays there after I cut it. And that's simply because a lot of times my left hand is already holding the thing that I need to tape, and then I go, oh shit, I need tape. And then with one hand, I can just reach out and get it. And then we've got mod number 3. This is a $70 tape robot that just gives me tape. And I have it set with presets that are my most used lengths, so they all fit my favorite boxes perfectly.
I'll tell you what, best $70 spent ever. I'm 100% putting that in the video. I'm 100%, I'm doing it.
This is why you should have 19,000 magnets at the ready at all times in multiple sizes, especially these magnets, the ones that have the holes for the screws. If one magnet is one wife, I'm King Solomon. Look at that, perfectly even. This is actually a monitor arm with a laptop stand attachment. Yes, you belong to me. Yes, dude. Yes. Look at it. Absolutely beautiful. Cheers to that, guy. Whether you're team cardboard spool or plastic spool, there is a world where they can live together. I'm going to show you a tip that I learned recently. I didn't know this was possible. Got your Pet G cardboard spool. Because this Elegoo Pet G is some of my favorites. Get your Spider-Man massaging hand. You're just going to, right? And then push up, rotate it. Really get in there. Going around, going here, lift up, and this carefully comes up. Make sure you keep that little piece of filament in there. Just leave it as is. Take your reusable spool. I know for a fact it works with the bamboo ones. Find the side that has the little notch on there, right? Keep holding it tight, flip it over. Get your Spider-Man or your Shocker Man, do the same thing. Take your other half of the spool, find it. Hey, get up, keep those two halves together. Locked and loaded. And then you got support of recycling, but still can use the reusable spools. Your handy dandy labeler. Look at you go. Because I work with almost exclusively Pet G and I dry it, the drying warps the cardboard and it causes issues in the AMS, and this fixes that. Despite how it looks, I'm not 3D printing a fleshlight. But this project did make me realize it is an option. Before I put this project on hold for a few weeks, there's one last thing I want to figure out. An optional adjustable support that you can put in the middle of the shelf to support the middle if you have a wide shelf. I played around with the idea of just a super basic support, and I was like, what if I use more screws? This works great, super easy to adjust, super easy to print. As a CAD beginner, doing screws in CAD has been pretty difficult. So unless you get these tolerances just right, you might have some wiggle, and it'll always be loose. Following the same theme of using some TPU for additional grip, what if I made a little TPU gasket that could help just add some friction? Got your fleshlight, you got your screw, and you just adds a good amount of friction, can still be adjusted easily, can go frontwards, backwards. This might work great. I didn't do any research on what would be good for I just thought of it and did it, and it works awesome. It's of course not as smooth. It gets a little sticky, but it's a fleshlight. It's going to be sticky.
I just learned you can do something cool in a slicer with QR codes, so I'm going to share with you.
Because sharing is caring.
Adult Lunchable, anybody? I have these limited edition collector's cards for products. I was trying to figure out how to use a QR code to actually just print it into the card. I came across this site, QR code to STL.printer.tools. You can either use an existing QR code that you trust, or you can have this tool generate one for you, and then it'll create an STL that you can download. And you can download each one of these assets as individual STLs. This is the back of my collector card. Right click, add modifier, and load. It does let you select multiple STLs at the same time. Hit open. Zoom all the way out because Orca put them in the stratosphere. Take this whole card, rotate it, select just those STLs, set that to a different color.
Slicey.
Move the modifier up a little bit right there.
Slice.
And now that QR code is baked right in there. Oh, it's upside down. Shout out to Figure Feedback who made a YouTube video about this. You get an adult Lunchable.
I 3D printed a mistake, but I fixed it. This is the boo-boo. See the boo-boo? But this is the woohoo. Woohoo! I use these 1/4 hex bolts, and they print like this so that the screw goes in mid-print, and then the printer prints right over. Every time I've done it this way, it's worked perfectly. This time, the filament didn't want to stick to the screw head, so they all fell over mid-print, and I was left with this. So I laid out a good old chunky boy cylinder, and I took this part, and I found the layer at which it failed, sliced it, and then in CAD, I took this, put it inside the cylinder, and then took a negative. But this could fit, and it could fit. And now it fits in there. And I printed it with fuzzy skin to give it some texture on the outside because it's a thumb screw, gives it better grip, and of course laying it down with my favorite glue of all time. I think this one's done. See? Woohoo! 3D printing life hack, mic arms and monitor arms. That guy. Needed an external spool holder. Like a $20 monitor arm. No friction. I'm reeling it back. Uh-oh. Little screw there to stop it. Comes off. Just hangs there. Another monitor arm. This one has a laptop stand on it. Perfect for holding the filament above. Look at that. It's perfect. It's an old microphone arm, and I just used that to blast light into this cabin. If you got them laying around, use them. Part 2 of the MagSafe monstrosity. Thank you, everybody, for the suggestions so far. Oh boy, Mandic, really teaching me something new. What I was doing before was isolating this and then exporting it as one STL, and then I would isolate the other part and then export that as an STL. From there, take both the STLs at the same time, drag them in, load it as a single object with multiple parts, and then I could come over here, interact with each one of those parts individually. What I didn't know is that you can just select both of the parts. So select these two, isolate them, export them. It makes a single STL, put it in. Whoa, where'd it go? Take that one STL, drag it into the slicer, and come over here and split into parts. Now, I don't know how it chooses what is a part because now there's 6 parts here. I don't know what all of the other parts are. I don't know if I can merge those. Oh, there they are. Those must be hidden polygons in my model. Well, regardless, that's new. Lightspeed brings up a good point here. Why not just make the entire part 4 or 5 walls, 50% infill? You know what video he's talking about? It's a CNC Kitchen video where he shows the diminishing returns of like how much percent infill is too much infill. Where do the benefits drop off? And that was his recommendation. 4 or 5 walls, 50% infill. But that got me thinking, if I only need the strength in that one place, does doing 5 walls, 50% infill for the entire part, is that a waste? Am I wasting time? Am I wasting filament? Let's find out together. 0.2 layer height, 5 walls, 50% infill, 32 gigabytes of filament, and an hour and 24 minutes. However, if I come over to my part, so the main housing of the part, 2 walls, 15% gyroid infill, and then just that interior part, 100% infill. Why didn't it change this to... I thought gyroid couldn't be 100% infill. Or is that Bamboo Studio that gives you that error? I can't remember. So rest of the part, 2 walls, 50%, interior part, 100%. And that is only 22 gigabytes of filament in 47 minutes. So I significantly cut down my print time and filament usage by doing it that way. So that's interesting. Not saying that CNC Kitchen is wrong at all here. I faintly remember all the testing CNC Kitchen did in his video. I can't remember if he did any like heat insert specific tests. It's like, yes, after 50% infill, diminishing return for the entire part. But if you're targeting just a portion of that one part, using 100% infill, considering heat inserts, you still have the same fall off of diminishing returns. There's no need to go above 50% infill or 4 or 5 walls, right? So as many people have commented, CNC Kitchen's testing of where are the diminishing returns of walls and infill. From what I remember from his video, I agree. However, what if we're talking about just a portion of the part being 100% infill? And I'm speaking before going and watching his video again, but my other question is, for threaded inserts inserted by heat specifically, do the same diminishing return rules apply? Because look at these 2 parts, right? You've got on the bottom the 5 walls, 50% infill through the entire part, and then the top one, which is 50% infill for the majority of the part, but then 100% infill for just the part around the threaded insert. The top one uses half the amount of filament and prints in half the time. So that makes me curious, between these two parts, so specifically talking about threaded inserts that are being inserted through heat, which is going to be stronger? The 5 walls, 50% for the entire part, or the 100% infill just around the threaded insert? I don't know. Makes me want to buy some scientific machine.
If you like building with magnets, you better buy some of this magic paper. Philips Hue Smart Switch gets me hot. Donde está el magneto? Bingo! Oh yeah, more. Add more. I wish someone would smash me just like this. Small nipples. Photogrammetry. More like photogrammetry. Jesus Christ, that's comedy. Make it pretty like Barney the dinosaur. Splash. Mega throb. These magnets be touching.
Wow, Luigi, wow. Wow. Last video about filament. Today. Well, I designed and printed this, which is meant to be for silicone. Print this, fill it with silicone, and then you get this. And then you fill the silicone with resin, and you get the NAC Habitat collector's card that I'm giving with these 3D printed kits. Somebody somewhere was raving about the Protopasta matte fiber. I was like, okay, I'll try it out. Pretty moderately priced. It's only $40 for 500 grams. However, when you're printing for silicone molds, you want the least amount of the layer lines possible. Tell me where the layer lines are. They are completely invisible. The top layer, you can see them a little bit, but just almost, there are none. As you can see, I ran out of the black filament, so I swapped in white near the end, but I have not found a better filament that prints so smooth for mold making. But if you have a suggestion and you want me to compare it, I'll do it.
First layer just absolutely cracked.
What do you get when you mix liquid kryptonite, a screw, really big wood, a bald guy, and a large flat piece of lumber? Oh, and 3D printers. So in the collector's edition of the most recent kits that I sold, I made these collector's cards. They are resin cards that have pieces of filament from the prototyping process. 3D printed template, fill it with silicone, and then you fill the silicone with resin, and you get those cards. My issue is nothing in this house is level, so I needed a way to level things. I had a couple of these little levels left over, and I designed this little caddy that they could sit in, and then they screw to the side of the board. The one there, so you can do both. And then in each corner, I designed a little thing, so I'm calling it a thing. It sits snug on the corner, screws in, heat threaded insert, and then use one of those screws to act as a level. Kind of like at the bottom of a piece of furniture. One on each corner, and screw that into place. And now when I pour the resin, it will be level. I was told to try this filament, and I haven't yet because they had a rainbow filament. My girlfriend is sleeping, I have to whisper. It's got some issues, but as far as the color and the gradient, it is the best looking rainbow filament I've ever used. It is so pretty. It is just the gorgeous of colors. I don't know why it's doing that. I gotta figure that out. She's awake.
Nobody gives him eye drops! Ah!
This was something I started working on a while back. Little storage containers with removable nameplates, tiny dovetails. Nice. A quick filament comparison. So this is the Bamboo PLA Matte, and this is the Bamboo PLA Basic. Both $19.99, same price. You can see just the difference in texture. Very, very glossy, very, very not glossy.
The PLA Basic looks like it could be tuned to be better, but just to give you an idea of the finish.
I mean, there's another representation. Just what a difference. Obviously, the matte one is going to scuff easier, so you can only use some depending on your project, but man, I love the way the matte looks compared to the basic.
If you are somebody who creates anything, do you remember the first time that you realized that you were different from other people?
read this comment and then listen to the story. So working construction was one of my first jobs, I remember. It was like my second job. I was like 16. And I was painting a business office, and I was painting above door jambs. And I remember my boss looked at me and said, Nick, you don't need to take so long painting above the door jamb. Nobody's going to see it. Nobody's going to see it from where they're standing. And my first thought was, well, I'm going to see it, and I'm going to know that it's there. The details matter, and doing something right matters. The rest of my life past that day has consisted of people telling me, you don't need to care about that, you don't need to do that much, you don't need to care that much. And I've given the middle finger to all of them, happily.
Never half-ass two things. Whole-ass one thing.
So everybody and their hot, horny dads has been talking about these new plates. Or not, they're new to me. Buddy, we got new plates. We got new plates.
First of all, non-performance related. It just brightens up the whole inside. It looks lovely. I bought this, by the way, not sponsored or affiliated yet. Birds line, clean. Parts. Ooh, easy detach. How about this one? Ooh. I definitely feel like there's like a bed honeymoon phase where first like 20 prints are just so good. It's that long term. You really figure out how good it is. For the most part, I've been doing the SliceWorks dipped PEI. That's a cold plate. The textured bamboo PEI. The smooth super tack from bamboo. Now those. And I destroyed this one with TPU. But you can tell though there's a little bit of a texture difference between those. They're all the same ones, but they look a little different. I feel like the dipped PEI do the best long-term durability-wise, but I have the most lifting with those. Super Tack's also very durable, but sometimes the prints fuse to this thing. So I am very curious to see how these stack up. I like how it has the longer tab. I monitor all my prints with network cameras from upstairs, and this on camera and just looking at it from outside the printer, I might keep it just because of that. How are you all storing your filament? Because I need suggestions. This basement is 41% water. So I got PET G in the box, everything else out the box. I know the rep rack exists. I don't want to mount anything on the wall. Do they have like a rep rack for desks?
Solo. Han Solo.
You want to nerd out on some styrofoam, shipping styrofoam for a second? I have a Creality Falcon laser, and I've been prototyping my own shipping materials. This is a future product that just stays snug in there. I love it. My dog's taking a shit outside. He's taking a shit. I got a package from Sunlu today, and it came with this. I thought it was just interlocking styrofoam. It's just partially cut, and it stays connected. And it's really on there. And so you can build it up like a cube, and it's all one piece, but I thought that was awesome. So kind of the same thought process, right? You just take a single piece of cardboard, laser it, and you can make shit like that. That's awesome. I had no idea how much moving 3D printers from one house to another house would mess me up. I live in Michigan. We have pretty high humidity. I moved from Michigan to Michigan. The last workshop was on the first floor with window air conditioner units. Average indoor humidity in the summer, 10 to 15%. It's almost 90 degrees here in Detroit. Right now in here, 55% humidity. PET G that I used to be able to leave out no problem, all has to be in sealed containers. If I only needed to do a couple days of printing, I could put PET G on an external roller, hang it up above the printer, and it'd be fine. Now, it either goes in a box or it's not printing. The problems that I never had, or it's been so long since I've had them, I'm now re-experiencing same printers, same files, just new house, new temperature, new environment. The temperature has not gone below 80 degrees in over 48 hours. It is super muggy down here. Me not thinking opened up this vent to bring some air conditioning down here. We have central air in this house. Not realizing when this vent is open, it's just blowing cold air directly onto the printer. So we have a makeshift air redirectioner now. It was time to change out my moisture sucker pellets, right? 37% in there. I took one of those out, and it's been sitting here for about a minute, 53%. The Sunlu dryer prototype hasn't been turned on in probably 48 hours. Just got some rolls in there, and it is currently at 43%. I'm only printing my own designs. They're all functional prints. I print 98% with PETG. This is why I tell people who are getting new into 3D printing, yeah, you're gonna have a great time with the Bamboo. You're still gonna have factors you're gonna have to deal with. It's not always going to be point-click print. I don't know how long I'm gonna be in this house. I might have to seal off this bench at some point if this becomes too much of an issue, because the amount of failed prints in this house compared to the last one.
Here's a quick demo on how I designed this 3-in-1 kind of snap-in-place faceplate design for an upcoming Elgato Prompter faceplate. Now, there's two main factors that make this all work. One is dovetails, and the other is flexibility, thanks to PETG filament. So I did a quick demo of this the other day. So there's the main faceplate, the first insert, and then the second insert, which is kind of a support. And if I show you this part from the top down, you can see there is a couple millimeters of straight channel, and then there is this curve right here, which is a dovetail. When this first plate is sliding in, you can see that it's not really going in straight. So there's some tension here that's causing it to curve a little bit. You can see there's a cutout for a notch, and that notch exists on this first plate only. These channels on the side are just high enough so that it is easy enough to slide in without lubricant, as well as allow that first plate to snap in. And the snapping is that little notch kind of fitting into the notch cutout. So the parts of the design to fiddle around with were how thin can this faceplate be? How high do these channels that create that tension need to be for that to snap into place as it should? So the first insert drops into place, and then the second insert, which is kind of a support, slides in over top of that. So on the back side of this faceplate, there is a subtraction of that dovetail so that that can slide into those channels. So the bottom of that support plate has dovetails so that it can lock into place on this face here, and then these channels here have basically the same dovetail angle that this has, so that this goes slides into place, and those channels on the side are creating that tension. So when that second insert reaches that same depth, those little lips at the top are snapping into place as well. Now, something that is a byproduct of this design, I totally did this by accident, is getting this top plate out was kind of annoying. Kind of had to grab it by these edges, and it was hurting my finger. Then I realized I can push on that first insert to get it out of place, and then both plates come out at the same time. I did that completely by accident. Can't really take credit for it. I did it, but I can't take credit for it.
How are you cleaning your build plate?
She asked a great question, but then you go into the comments and you see a bunch of blanket statement responses. Water, alcohol, urine. There is no one answer for cleaning bed plates. If I learned anything in the past 2 years. Use for this is going to be different than what I use for that. It's going to be different from what I use for that. It's going to be different to what I use for that. Textured PEI from Bamboo. Detergent and water. CryoGrip Glacier, water and soap or alcohol. CryoGrip Frostbite, I know they look alike, they're different. Water and soap only, no alcohol. Bamboo Super Tack, it's a cool plate. Water and detergent, never alcohol. Laceworks, this is a dipped cool plate. Never IPA, alcohol, or acetone. No detergents. Just water. Community will never agree on bed adhesion liquids like glues or release agents, even though the other side is wrong and things like this are good, because it depends. We need to all come together and say no glue sticks or hairspray anymore. Somebody give me a reason why either of those should be recommended over things like Hyperlock or the Bamboo or Vision Miner. Please. Even though I use 70% IPA to clean my PEI sheets, IPA isn't a degreaser. I don't recommend anybody do this. I use Simple Green 4:1, then a 4:1 ratio, every once in a while as a degreaser, and then I go over it again with IPA. And I never have any issues with bed adhesion. It's never really an issue. After a few weeks of printing, my verdict is these things suck at failing. I probably had 30 prints total. That was PETG. I really only had an issue with like long and skinny prints, but I kind of always have that issue with PETG. Also, I went from printing on first floor in a house with no central air to being in a basement that has central air. So I feel it is significantly colder in this room. So I do find that I need to use brims more often. Lastly, because I use network cameras to monitor my prints, the blue provides like a really good contrast from prints to bed. I'm happy I bought them. They've been great.
All right, I think I got the support filament for PETG working.
Here's what I changed based on what I read. But first, look at this. Avoid printing individual models. Well, that sucks. Their nozzle temp gives that range. Default temps for that filament was 220. So I upped it to 230. So changed the minimum to 230. The top interface to 3 layers instead of 2. And I put the initial layer density to 100% instead of the 90 that was default. Both filaments through the dryers again. Cleaned the bed plate. I put the flushing volumes to 900 for both.
and then put the multiplier to 2. What else I didn't catch at first for a couple of those other prints? Prime tower for one of my default profiles was turned off. Only 2 that I did today. Still effective. Moment of truth. Look at that. Wow. Did not have assumed that the slicer settings for the support filament matched what their online documentation said. Lesson learned.
I've only ever printed one spool holder for the big boys, and it's this one. Right side is one piece, the left side is one piece, and then these two go together, and there's bearings in each of the sides. What's nice is because this is a self-centering one, if you don't want to use a large roll, and you just want to use an itty-bitty roll, it works all the same. Oh, I'll show you the model that I use next. If you have one that you like, comment it to help this person out. There's this one right here by 3D Sorcerer. What a clever name. Comes in 3 different sizes. It's been very good to me so far. This little pillar of opportunity, this is why I tell people design things from scratch, even if you can download it. It's beneficial for you long term. So this is a shelf bracket that I'm using for this shelf kit. Spent a bunch of time designing the clamping mechanism for that bracket, and I said, you know what, I would really like to get these in the air. And I thought, you know what, I could probably use it again. And I did. I was able to take that same clamping mechanism and adapt it to this new design, which is going to be a speaker stand. It's going to be just like that. If you keep designing and designing, you'll eventually build yourself a library of models and designs that you can reference. The amount of models that I pulled from other projects and used them for new ones happens all the time.